In this video, I am going to improve the performance of the database queries by using the lean function. Here, the getBlocks function returns the list of blocks. Let's first test the performance. And make sure to remove the auth middleware here before loading the test. As usual, I'm testing it with thousands of requests and 10 requests at a time. So it has responded with the matrix data, and it took about 1.75 seconds. So now let me add the lean function at the end of the function chains, and I will test it. It's as simple as that. Now let me load and test it again. You can see that it made almost 3 milliseconds of improvement. So the lean function makes sure that to return plain JavaScript objects instead of Mongoose documents. This is particularly useful for reducing memory usage and improving performance when you don't need Mongoose's full document functionality, such as getters, setters, virtuals, and methods. On the other hand, when you execute a query without calling lean, it returns a Mongoose document, which has a lot of additional methods and properties added by Mongoose. The lean method tells Mongoose to return a plain JavaScript object instead of Mongoose document, and that's what makes it fast. So why not use the lean method on every Mongoose query if it improves the performance? As I said, the lean method returns a plain JavaScript, so it comes with some limitations, such as casting invalidation, getters and setters, virtuals, and the save function doesn't work with lean. Since it bypasses the schema layer and directly returns a plain JavaScript object, the custom logic in your getters and setters is not applied. So it's usually optimal for find operation, and let's see an example with getters. So the getter function will capitalize the first letter of the title. I am going to add a get property, which is a function that takes a value. And here, let me return a new value. So car at 0 returns the first character in the string, and then it changes it to uppercase. Now, let me add the rest of the character. The slice method returns everything, starting from the index 1, which is from the second letter. Let me fix the lint issue and check the log. It's working perfectly, and now let me enable the getter in this schema. Here, let me add an object with toJSON attribute and set the getters to true. The JSON here should be in capital letters. Okay, let me first test the getters with lean. You can see the first letter is not uppercase. It means the getter is not working. Let me comment this out and test it again. The getter is now working, except for the space here. So let me remove the space and I will send a request again. Perfect. It looks great now, but what if you want to use the lean method together with getters? So there's a package for that, which is called Mongoose Lean Getters. It's quite simple to use. You first import it, and then it's added as a plugin. And whenever you call the lean function, you should set the getters to true. So you can play with it by yourself, and this is pretty much it for this video. In this video, we'll see another interesting way of improving the performance of data retrieval operations by using an index. An index in a database is similar to an index in a book. It provides a quick way to look up information by creating a separate data structure to store some part of the data. The columns that are frequently accessed or searched, such as the email in the user table, should be indexed for better performance. So let me scroll down to the bottom and add the email as an index. Here, let's call the user schema.index, which takes an object with the column name and the sort order, which is 1 or -1. 1 is for ascending and -1 is for descending order. So Mongoose will create a separate data structure that stores the email in a sorted and efficient format so that when it's accessed in a query, it can easily be found. Now, let me also add another index inside the blog model. So here, a user can search for a blog using the title and the description. One way to do that is by using the find function and filtering the data using the title and the description. But to make it better, I am going to combine index and full text search. Full text search is a technique used in database to find data based on the content of the text rather than the exact match. So the first step is to create a text index for the title and description. Okay, let me scroll down to the bottom and call blog schema.index, which takes an object that has a title attribute set to text and also a description set to text. As you can see, it is a bit different than the email index because this is a text index and I added it as a text. Now, let me close this file and head to the blog route. Here, I have already added a search route, so let's head to the controller and take a look at the search function. I also added the controller function. It's just a regular function, and I'm going to add the implementation here. Let me first create the search query variable, which has a request query value. Now, let me call blog service.search blogs, and I am going to pass the search query I just created. And let me assign it to a blog variable. Now, I am going to respond with the blogs as JSON. The controller is ready. Let's now implement the service for it. It takes the search query as an argument. And let me now create a blog variable, which is a result of a search using the find method. And it takes the text search operator, which has an attribute of search. So this will find anything that's indexed as text. And let me return the blogs. Cool. Let's test it and see how it responds. Here, let me add a blog search blog URL, and under the params tab, I am going to add the search query. Let's say Node.js, and I will send the request. Okay, it's asking me to authenticate, so let me quickly log in and get the token. I am going to copy this and paste it into the authorization header of the search route. Let me send the request again. It's returning an empty array. That is because I forgot to add space here. So if it contains any word like that in the text, it will add it to the result, and it doesn't need to match the entire text. So let's head to the database and see the indexes. So in the block collection, there is an indexes folder containing all the ID and all other indexes. So thanks for watching all the videos. I hope you have learned a lot of valuable lessons, and I will hopefully add more to the course and come up with more interesting sections or projects, so stay tuned till then.